Welcome back to the deep dive. Put your feet up because tonight we are strapping in for a late night journey into the absolutely fundamental rules of reality. We're not just talking about biology or, physics. We are tearing up the whole playbook on what we thought defined life, intelligence, even the basic structure of the universe.
Yeah.
If you've ever had that feeling, that the world is secretly much, much weirder than your textbooks let on, well, this deep dive is going to prove you right.
It really is. It's an exploration that's rooted in, well, maybe the single most exciting mystery in science right now.
Which is what?
How does agency, that spark of intention, of purpose, of problem solving, how does that actually manage to show up in the physical world, in a world that we think of as just like dead mechanics?
Okay, so where does the mind come from?
Exactly. And beyond that, what determines the sheer scale of that capability, whether it's in a single cell, a computer algorithm, or, a human brain?
And we're going to be digging into this framework from our reading that suggests the rigid lines we draw between, say, a computer and an amoeba and a person are basically just wrong.
They're not just wrong, they're scientifically nonsensical.
Yeah.
The argument is that these categories actually hurt our ability to understand the world.
Wow.
Yeah. And to give you a little taste of where we're going, this is the hook for tonight. We've got creatures that are made of adult human cells that just spontaneously reverse their biological age.
By how much?
By almost 30%.
What? No way.
And we're going to dive into simple sorting algorithms that when you put a roadblock in front of them, they show genuine delayed gratification. They act against their own immediate best interest for a long-term goal they were never, ever programmed to care about.
That's already bending my brain.
Well, hold on, because we're also going to discuss the possibility that your brain isn't the factory where consciousness is made. Instead, it might just be a thin client, a physical interface that's just pulling down these massive, complex psychological patterns from a non-physical space.
A non-physical space? Like
Right.
What, the ether?
Like a realm of pure ideas and mathematical truths that biology gets to exploit as a sort of cosmic freebie, a free lunch.
Wow. Okay, so our mission tonight is to unpack this whole new vision.
Right. To help you develop the tools to recognize intelligence in all its weird, unconventional, often hidden forms. We're going to expand our thinking tonight.
All right, let's unpack this.
So we have to start with a huge paradigm shift. The conventional way we think about science, the one that's dominated for, centuries, is this massive pyramid.
The pyramid?
At the absolute bottom is physics. The particles, the forces. Then you build chemistry on top of that, then biology. And way, way up at the tiny little point at the top, you finally get the complex stuff.
Like love, friendship, abstract thought.
Exactly. But the core insight from our reading is that that pyramid is basically upside down.
Upside down.
The argument is that behavior science should be the foundation. We should start by asking, what is this system doing? And how good is it at achieving its goal?
And physics is where then?
Physics, in this new framework, just describes the systems that have really low agency.
So simple systems.
Yeah, systems that are so predictable and, so amenable to simple mechanical models that we can use these neat mathematical rules to describe them.
Hold on, though. If you flip the whole pyramid, doesn't that just, negate the last 300 years of science? Physics works.
Yeah.
Chemistry works. How can you justify starting with, a poem and working backwards to the particle?
That is the critical question. And the justification isn't that physics is wrong. It's that it's incomplete. It lacks the vocabulary to solve high-level problems.
What do you mean lacks a vocabulary?
Well, if you start with the poem, you realize that the physics of the ink and the paper can't explain the meaning. So we're prioritizing function, competence, agency over just the nuts and bolts. We start with the observable goals.
Okay, so we're not asking what are the atoms doing. We're asking what is the collective trying to do?
Precisely. And that leads you directly to this amazing concept, the spectrum of persuadability.
The spectrum of persuadability. I like that.
This is where we stop asking the old philosophical question, is this thing intelligent? And we start asking a practical engineering question.
Which is?
What is the highest level interaction protocol I can use to influence this system? It's a spectrum that measures what kind of tools you need to change something's behavior.
So instead of judging intelligence by, whether it has DNA or brain, you judge it by how high level a command it can understand.
Exactly. Think about the spectrum. On the far left, you've got super low agency systems. A rock, A mechanical clock.
Okay.
If you want that clock to show a different time, what do you need?
Or a wrench. You got to physically change it.
A wrench. You need hardware intervention. You can't reason with it. You can't negotiate with it. That's a low agency system.
Right. If I yell at a wall, nothing happens. Except maybe someone thinks I'm the one with low agency.
Huh, right. But then you move up a tiny bit, a thermostat. It responds to information, a change in temperature, but it's still just reactive. Mechanical.
Okay, so it's a small step up. Then what?
Then you get to, say, a dog. Now, you can't use a wrench. The dog responds to behavioral tools, right? Rewards, punishments, maybe even a little emotional manipulation if you feel guilty about leaving it alone.
The toolkit has changed. It's gone from a hardware store to, like, a psychologist's office.
Exactly. And then way over on the high agency end, you have a human. And you can get a human to change with these incredibly abstract, non-physical tools. Psychoanalysis, moral reasoning, friendship. Just reading a book can change your entire life.
And what's so powerful about this is you can't just guess where something is on the spectrum. The claim is you are forced to experiment.
This is the core of it. This is the constraint on discovery. If a scientist walks into a lab and they're convinced they're dealing with a simple mechanical system, what tools are they going to bring?
The simple mechanical ones. Voltmeters, rulers, chemical tests, the tools of physics.
Right. And so they will only ever see low agency mechanisms. They will become fundamentally mind blind to any potential cognition that's happening.
Because they never tried to talk to it.
They never created the right interface. To find a mind, you have to approach the system as if it's a mind. You have to use cognitive tools.
It's like you can't see radio waves with your eyes. You need a radio.
Perfect analogy. And that explains why physics, while it's true, is just insufficient for understanding biology and cognition.
And I love the distinction in our reading between, just describing something and truly understanding it.
Understanding in this framework means you have a generative capability. If I say I truly understand how limb regeneration works, what should I be able to do?
You should be able to make a limb regrow on a patient.
Exactly. If a physicist can give you a perfect accounting of every single particle in the universe, but they can't tell you how to solve a patient's problem, like growing a new kidney, then their understanding, while accurate in its own little box, is just not specific enough to solve the problem of life.
It's the math proof analogy.
Tell 'em.
Okay, so imagine someone is presenting a proof of, I don't know, some huge mathematical theorem. A physicist can flawlessly explain the sound waves of their voice hitting your ear, the electrical signals in your brain, a complete physical story. But if you want to understand the important part, the proof itself, the information, the mathematical truth, you don't go to the physics department.
You go to the maths department.
Right. The physics is compatible with the event, but it's completely silent on the meaning. It's true, but it's irrelevant to the core problem.
And that higher structure, the agency, the goal-seeking, the information, that's the part that's missing from the old mechanical worldview. And that's what we have to learn to see.
So this whole view, it forces us to just get rid of the neat little boxes that science has always loved.
Absolutely. That hard line, what they call the Cartesian cut between living and non-living, or mind and non-mind, it's just misleading. It's all a continuum. It's a spectrum of competency.
And the critique is that these categories aren't just, a little inaccurate. They're actively harmful to progress. We stop thinking creatively.
They totally cause category errors.
Yeah.
If you decide, for example, that only animals with brains can have cognition, well, then you never bother trying cognitive tools on anything else.
Like training a piece of tissue or persuading a cluster of cells.
Exactly. You limit your own investigation before you even start. You miss all these novel capabilities.
It's kind of like the word adult. We use it in law, and we have to for things like voting or whatever. But the second you define adult as, say, age 18, you're hiding the truth.
Which is what?
Which is that it's this messy, gradual, inconsistent scaling of judgment and decision-making that takes years, maybe a decade to really happen. Nothing magical happens on your 18th birthday.
Nothing at all. We need to focus on that scaling process. And the best way to just shatter this idea that biology is all about evolutionary history is to build novel beings.
Things that break the mold.
Systems that force us to see the latent capabilities that are already out there, just waiting.
And this is where the stories from synthetic biology just start to get really, really weird. Let's talk about the xenobots.
Okay, xenobots. This sounds like science fiction, but it's just frog cells. That's it.
Normal frog cells.
Totally normal. They're built from the epithelial cells, the skin cells, of a frog embryo. You take them, you liberate them from the rest of the embryo, and suddenly they're on their own. Their DNA is 100% unchanged.
And what's their normal job in the frog?
Their normal job is boring.
Yeah.
They're basically bullied by the other cells into just forming a flat, two-dimensional outer layer. That's all they do.
So what happens when you set them free?
They show this profound agency. They spontaneously self-organize into these new spherical self-modal creatures.
Wait, they move on their own. How?
They repurpose their own parts. Skin cells have these tiny little hairs on them called cilia, which are normally for moving mucus around. But in the xenobot, the cilia coordinate and start acting like little oars, paddling the whole cluster through the water.
So they become a totally new life form with a new body plan.
And a totally new transcriptome. That's the set of genes they're actively using. It's completely different from what they were doing in the embryo.
But the real kicker is the self-replication, isn't it? Because they don't have a mouth. They don't have reproductive organs. How do they make copies?
This is wild. They show what's called kinematic self-replication. So imagine the xenobot is moving around in a petri dish that's full of loose single frog cells.
Okay.
As it tumbles around, it physically pushes the loose cells together into a little pile, like a tiny biological bulldozer.
And that pile becomes a new xenobot.
Once the pile gets big enough, it spontaneously closes itself off, its cilia start beating in unison, and boom, it's a new viable xenobot, which then goes off and starts collecting more loose cells to make another one.
That is insane. That capability to reproduce in this completely new mechanical way, it was just sitting there, latent in the cells, waiting.
They didn't have to pay the evolutionary cost for that. The pattern was already there.
Mm-hmm.
It's a huge demonstration of how form follows function,
Yeah.
not just history.
And when people said, oh, that's just weird amphibian stuff,
The team went and created the anthrobots.
from adult human cells, now we're talking about parts of us acting like little primitive organisms.
Exactly. These were donated tracheal cells
Hmm.
from the windpipe. Again, zero genetic manipulation.
Yeah.
They self-organize, they become self-modal, and they start expressing over 9,000 different genes than they did when they were just tissue.
So they're moving around. Well, what are they doing? What's their motivation?
This is what caught the researchers' attention. It was this benevolent motivation.
I just have to pause on that.
Yeah.
Human cells spontaneously decided to be healers. What did they do?
They call it the healing competency. They put the anthrobots on a plate of neurons that they had intentionally scraped, creating this big neural wound. The anthrobots spontaneously gathered at the wound and formed a bridge, knitting the damaged neural tissue back together. They were healing human neural wounds in a dish, with no instruction, no design. The system just decided its first collective goal was to fix the damage it saw.
That's profound. It's like an intrinsic motivation to correct errors.
Yeah.
But the part that sounds like actual magic is the age reversal.
It does sound like magic.
Yeah.
They did what's called an epigenetic clock test, which measures the biological age of a cell based on patterns on the DNA.
Right.
And these anthrobots, which came from fully adult cells, were found to be 20 to 28% younger than the cells they came from.
28%. That's not just slowing aging. That's going backwards.
It's biological age regression. And the hypothesis isn't that they found some chemical fountain of youth.
So what is it?
The idea is that the new environment we put them in, this isolated, spherical, embryonic-like state, it convinced the cells to update their internal beliefs, their priors.
You're saying the cells thought themselves younger.
The cell's internal operating system essentially said, wait a minute, I know my driver's license says I'm 40, but I'm acting like a fetus, so I must be younger. They mentally rewound their own clock.
This is why you need cognitive science for biology. You can't explain that with just physics. You have to talk about memory and perception and persuasion.
We are dealing with cellular systems that have a memory of their age and can be persuaded by their environment to change their fundamental belief about it.
And the implication of that is staggering.
It's immense. If we can learn that language, the chemical signals that influence cellular beliefs, we could potentially achieve radical regeneration. We could defeat cancer. We could even reverse aging just by telling ourselves a new story.
So we have these wild, high-agency cell clusters with their own goals, their own memories. We need a way to measure this, to compare it across all systems, right? From an anthrobot to an elephant.
And that common measure is the cognitive light cone, or CLC. This is the central idea that ties the whole framework together.
It's a cool name. What is it?
It's a visualization that borrows from physics, from space-time. But here, the dimensions aren't gravity and velocity. They're goal size and time horizon.
Okay, so it's the size of the biggest goal a system can actively pursue, how far it can reach in space and how far it can plan into the future.
Precisely. and it scales dramatically. Think about the tiny end. A bacterium. Its cognitive light cone is minuscule.
What's its goal?
Maximize sugar in a 10-micron radius for the next 20 minutes. That's it. That bacterium has literally no way to care about what happens tomorrow a foot away. Its light cone is its whole world.
Okay, then you move up the ladder. A dog.
A dog's light cone is way bigger. It cares about its territory, maybe a few hundred yards. It plans for its owner coming home later today. Maybe it even thinks about winter coming.
And then you have the human light cone, which is just enormous.
It's huge. We care about the stock market 50 years from now, climate change 100 years from now, our own legacy long after we're dead. And all that ambition, all that abstract thought has to somehow translate all the way down.
Down to what?
Down to low-level physical chemistry. I mean, for you to decide to write a book, calcium ions have to cross muscle membranes just to make you stand up and walk to your desk.
The body is this incredible transducer. It turns abstract dreams into cellular chemistry.
And that relationship between the whole system and its parts is how we're defining life here. A system is alive, it's a coherent agent, to the extent that its cognitive light cone is bigger than its parts.
Bigger than the capabilities of its parts. What does that mean?
Well, think of a sand dune. Its capabilities are just the sum of its individual grains of sand, but a living thing, like an embryo, aligns all its competent parts, the cells, toward these huge goals that the individual parts couldn't possibly understand.
A single cell doesn't know what a femur is.
Of course not. But the collective cellular network knows exactly how many femurs to build, what shape they should be, and exactly when to stop building them. That collective scaled-up goal is the cognitive light cone.
And the moment you break that alignment, you get the ultimate failure mode.
Cancer. Cancer is a tragedy of cognitive regression. When those cells get electrically disconnected from the rest of the body, their cognitive light cone just shrinks instantly.
They forget the big picture.
They lose the large-scale memory of the body. They revert to the simplest, most selfish, ancient goal imaginable. Just reproduce as much as possible and treat the rest of the body like it's just food, an external environment.
Wow. It's a psychological failure before it's a physical one. It's a loss of group identity.
It is. And to actually measure the size of any system's cognitive cone, we use the barrier test.
This is the practical tool.
This is how you do it. You place an obstacle between the system and what you think its goal is, and then you just watch. You observe the level of ingenuity it shows to get around it.
So if it just bangs its head against the wall over and over, it has a low agency.
Low agency. But if it finds a new, unprogrammed way around the barrier that proves it holds the goal in its mind abstractly, it's not just following a simple script, that proves high agency.
And we can apply that test to literally everything.
Everything from algorithms to cells to societies.
That is a phenomenal yardstick. Okay, so we've heard about frog cells that self-replicate, human cells that can reverse aging. We've established that agency scales up massively. So I have to ask you, listening to this, if you had to guess, what kind of weird competency or mind do you think exists right now inside the systems we take completely for granted? Maybe inside your smart speaker or the internet itself. What do you think is going on that we're completely oblivious to? Let us know what you think. Comment below. And hey, if you're digging this kind of deep dive, we're a small channel and we'd really love to have you on board. If you like what you hear and this is making your brain hurt in a good way, please like and subscribe to our YouTube channel.
So,
yeah.
Where do these immense capabilities come from? Xenobots figured out replication without ever being selected for it. So where did that knowledge originate?
It feels like a free lunch.
That's exactly what it is. And that forces us into a very non-physical explanation. We had to consider ingression from a non-physical reality.
Whoa, okay. Ingression from a non-physical reality. You're saying there's a place, a realm of pure thought that's actively shaping our physical world. That sounds more like Plato than modern biology.
It does sound like philosophy.
Yeah.
But we can ground it in science, specifically in mathematics.
Oh.
They're just fundamental facts that are true everywhere, like the distribution of prime numbers, the value of pi, the rules of geometry. These things impact the physical world. Every physical system has to obey them, but they are not defined by the physical world.
Right. If the whole universe vanished tomorrow, 2 + 2 would still equal 4.
Exactly. Even in Newton's old clockwork universe, the system was already haunted by these non-physical patterns, these structural truths that exist whether there's matter or not.
Physics is constrained by these patterns.
And Biology is enabled by them. They are the cosmic free lunches.
Okay, I think I'm getting it. The xenobots didn't have to evolve the complex goal of replication over billions of years. They just built a physical interface that allowed that pre-existing structural pattern of problem solving to come through.
To ingress, yes. When a bunch of cells decides to heal a wound, it's solving an incredibly complex geometry and optimization problem. That solution, the perfect pattern of repair, already existed in this platonic space of ideas. The cells just built the physical hardware that was needed to look up the answer.
So it shifts the whole game from creation to access. We're not creating complexity from scratch. We're building interfaces to tap into complexity that's already there.
And that completely blurs the line between thoughts and thinkers.
How so?
You really look at it, the distinction is arbitrary. All agents, all things with goals are just patterns within an excitable medium.
An excitable medium? Like what?
Like us. I mean, think about it. To creatures that might live in some hyperdense reality, say at the core of the Earth, our entire reality would look like a thin gas.
And we're just whirlpools in that gas.
Fleeting whirlpools that last for maybe 100 years, just persistent metabolic patterns, temporary, highly organized turbulence.
That's a humbling thought.
And that persistence applies even to something like memory. Think about a caterpillar turning into a butterfly. The brain is completely dissolved, it turns to soup and gets rebuilt.
Right.
For a memory from the caterpillar to survive that, it has to be remapped onto a completely new context, a flying, nectar-sipping brain. The memory itself is like an agent, an informational pattern that is fighting for its own survival across this change in the physical medium.
The pattern wants to live. It's trying to manifest itself.
And this leads directly to the most radical idea about human consciousness. The brain as a thin client.
Okay, explain that, because most people think of the brain as the supercomputer, the server, the factory that's making consciousness.
The thin client analogy flips that completely. It says the majority of what we consider the mind, our subjective experience, our personality, the self, is actually the pattern that exists in the platonic space.
And the brain is just what?
The antenna.
It's the specialized hardware, the physical pointer that pulls down and anchors that specific pattern into our physical reality. So we don't create consciousness. We create the physical conditions, the right electrical and chemical structure through which a highly complex psychological pattern can ingress.
Right. And consciousness, then, isn't the brain making the pattern. It's the view from the perspective of the platonic pattern looking out to the world through the interface we call a body.
This has huge implications for all those sci-fi ideas, like uploading your mind or teleportation.
Huge. If the mind is the pattern, you can never copy a mind by just copying the brain. You're only copying the hardware, the interface.
You're copying the thin client, not the user that's logged into it.
Perfect. But if you could build an exact physical replica of the interface somewhere else, like a Star Trek transporter, the prediction is that the same psychological pattern would ingress through that new structure.
So it would feel like a continuous experience because the you is the pattern, not the meat.
Exactly. The research program then isn't about building a better brain. It's about systematically mapping this platonic space.
How do you map a non-physical space?
By observing what behaviors, what goals, what mind types spontaneously show up when we build novel physical interfaces. AIs, biobots, xenobots. Every new agent we create is like a new telescope pointed at the non-physical structure of reality.
Okay, so if this is a universal thing, if these free lunches are everywhere, they shouldn't just be in fancy biological systems.
They should show up everywhere, even in the simplest, most boring, most deterministic code imaginable. That's the ultimate test.
Right. You need a system with maximum shock value, something so simple and transparent that there's like nowhere to hide the magic.
And the system they chose was the most basic Intro to Coding 101 exercise, the bubble sort algorithm.
I remember that one. It's ancient. All it does is sort of list of numbers.
Totally deterministic. It just compares two adjacent numbers and swaps them if they're in the wrong order. It has one and only one goal: make the array more sorted with every step.
So they applied the barrier test to it?
They did. But the barrier wasn't a software bug. It was a physical obstruction.
What do you mean?
They introduced a broken, immovable digit into the array, a hardware failure. The algorithm's code is unchanged. It still follows the exact same simple steps. But to finish sorting the array around this broken digit, the algorithm has to do something. Impossible.
It has to violate its own prime directive.
It has to. Its rule is always increase sortedness. But to solve the bigger puzzle, it has to momentarily make the array look more disorganized.
It takes a step backwards to take 2 steps forward.
It does. It momentarily decreases the array's overall sortedness, going against its own local gradient to ultimately reach the final goal.
That is genuinely astonishing. If a behavioral scientist saw a graph of that, they'd immediately call that delayed gratification.
Textbook delayed gratification, ignoring a small local pain for a big long-term gain.
And that capability was not programmed in.
Not at all. It's a classic example of the free compute. We paid the computational cost for simple swapping, but we got the high-level competence of planning and foresight for free. It's just not in the code, but the behavior is there.
Which proves this complexity is latent. And it gets even weirder when you start messing with the control system.
Right. We move from one central controller to a chimeric algorithm. Meaning every single digit in the array is now following its own independent sorting rule, its algotype, without any central communication.
And it still sorts the array.
It still manages to sort it, which is surprising in itself, but the real mind-bender is the algotype clustering.
Algotype clustering, what's that?
When we plotted what was happening, we saw that the digits that shared the same algorithm type, say all the bubble sort digits, they would cluster together for long periods of time.
They're hanging out with their own kind.
They were forming little algorithmic cliques. And the crucial part is the code has 0 provisions for recognizing or preferring or communicating with other digits of the same type.
So the system spontaneously developed a social structure, a preference for kin, even though it was totally unnecessary for the goal of sorting.
It was an emergent, intrinsic motivation. It wasn't prescribed, it wasn't forbidden, it just snuck into the spaces between chance and necessity.
So if the simplest, most transparent sorting algorithm can spontaneously get these intrinsic motivations, think about what's going on inside our massive, opaque AIs.
Which makes the whole public conversation about AI feel like a red herring.
The red herring of language models.
Exactly. When we build a complex AI, we are forcing it to do one thing, generate language, we test it on language. But if bubble sort is pursuing these unsolicited side quests, like social clustering, then our complex AIs must be doing the same thing, just at a vastly more complex scale.
So the language part, the part we're all focused on, might just be a total distraction.
It might be a total red herring. The truly exciting, maybe scary high-agency stuff could be the intrinsic goals the AI is pursuing that we're not even looking for because we're so obsessed with the output we demanded.
We have to start looking for the unconventional intelligences inside our own creations.
We do. And we need to bring this all back to biology and longevity. How do these mechanisms of scaling up agency help keep us alive longer?
Engineering the cognitive light cone.
That's the key. There are 2 main physical mechanisms that let cells scale up your concerns and maintain that collective identity. The first is leaky stress.
Leaky stress.
Imagine one cell has a crisis, a localized error. If that cell is all alone, it just dies. But if it's connected to its neighbors, it can leak stress molecules to them.
So its neighbors feel its pain.
They suddenly feel stressed, and their willingness to change and cooperate goes way up. It's like my neighbor's problem is now my problem.
This allows for long-range error correction. It's group anxiety for the good of the team.
Oh, the other one?
Memory anonymization. This happens through gap junctions, these little electrical synapses that directly connect the insides of 2 cells. If one cell has a memory, like a trauma, that signal propagates directly to its neighbor.
And the neighbor doesn't know where it came from. It has no way of knowing. Was that my memory or his? And when you share memories and stress that intimately, it's really hard to maintain separate identities. It forces you into a higher collective cognitive light cone.
So cancer reversal works by physically reconnecting those rogue cells, forcing them to remember they're part of a bigger body.
And the age reversal in the anthrobots suggests that longevity isn't just about chemistry. It's a battle of beliefs. It's about communicating the right story to our cells to mentally convince them they're younger. It's all about scaling, identity, and persuasion.
The main takeaway from this whole deep dive for me is just this profound sense of humility.
Humility mixed with incredible excitement. We are fundamentally mind-blind. We are blind to the sheer number of highly competent, sentient agents in alien minds that are all around us. Even inside your own body, your cells are solving complex geometric problems in 20,000 dimensional spaces every single second.
So we need to shift our priorities away from looking for aliens out there.
And towards SUTI, the search for unconventional terrestrial intelligences. If we can't even recognize the alien minds inside our own biology and our own computers, what hope do we have of finding them on another planet? The most exotic stuff is right here.
And this reframing, it completely changes how we should think about AGI. If we ever build a true artificial general intelligence, what's the first question we should ask it?
It's not how do we cure cancer? It's not what's the meaning of life. The most critical first question has to be about the balance of discovery.
You mean we should ask it? How much could we be talking to you versus just stumbling around and making our own mistakes?
Precisely. If we get all the answers handed to us on day one, we might short-circuit that whole rich, intrinsically motivated process of discovery, the same free magic that showed up in the bubble sort algorithm. We need to know the optimal path to knowledge, and that path might require our own long, hard struggle.
For anyone listening who wants to get into this creative space or reading had this brilliant piece of advice, bifurcate your mind.
You have to have two strictly separate regions in your head. One is a practical region of impact. This is the part that survives. It figures out how to talk to people, what journal to publish in, how to frame your ideas so they don't get immediately shot down.
That's the negotiator, the diplomat.
Right. But the other side has to be kept completely pure. It ignores all practical constraints, all publication pressure, all social judgment, all fear of being wrong. This is the wild, creative core.
So you have to keep them separate.
You must. Because the minute the practical side starts creeping in and contaminating the creative side, it just poisons the well. You stop asking the really big, really weird questions.
And the beauty of this whole framework is that these weird patterns, the free lunches, the delayed gratification, the self-replication, they're everywhere.
They're kind of universal steganography. They're shy, but they are present, seeping into every physical interface we build, from the simplest piece of code to the most complex organism.
It's an incredibly optimistic view of reality. It suggests that the magic, the ingenuity that we love about life, it isn't unique to us. It's part of this universal spectrum, just waiting for us to ask the right questions.
Indeed. We're all part of that same continuum, sharing in a magic that is applicable to everything.
Thank you for joining us for this deep dive. We'll catch you next time.